So let me give you the solution for this exercise. So in here, what you need to do is to have a list of string right here. And here I'm going to call this as names equals to new and then array list. Now I need to loop through. So here, this list, so array list of names. So I'm going to say arrays list of names dot for each. This will take names, or let me just say strings, because names is already taken right here. And what I want to do is inside, I want to say names dot add and then all and then strings. There we go. And we can even use lambda with method reference, just like that. And then we can say south and then names. Or if you don't want to use this, another way of you doing this is for, and then here list of strings right here. And then I'm going to say strings and then in array list of names. And we can just say names dot add all and then strings. So this is the exact same thing, but I'll let you decide what you want to use. But if I run this, have a look. So this was the initial list, which was a list of lists. So you can see that this is the main list. And inside we have one list of strings, another list of strings, yet another list of strings. So what I've done here is I've basically combined all of those lists into one single list. But again, we are learning about declarative programming and approach. And you can see here we are defining the list, we are looping, adding, and then printing. So you can see that there are a lot. So you can see that there are a lot of moving parts. So this is where flat map comes into play. To solve the above problem with flat map, we have to do the following. So here, let's together say names. So, or actually array list of names dot and then stream. And in here we can say dot and then flat map. And the flat map takes something really interesting. So here, if I press Command P, have a look, it's a function. And you can see that the generics in there are a little bit confusing to understand. But in essence, what we have to do is say list and then column, and then stream. Now, what I want to do is, so in here, let me just extract this to a variable because it's always good for you to see what is happening, right? So you can see that this is a function that takes a list of strings, which is our array list of names, and then it returns a stream, which extends anything that extends basically a string, right? So this is what the list.stream does. So let me just put it back, and now we can just say dot and then collect to a list. So collectors to list. If I put this on a new line, the same here. And now let me extract this to a variable, and I'm going to name this as names, and we are good to go. So you can see that instead of us having to define an empty list, have the loop, add the names, so on and so forth, we can just use flat map. Have a look. So this is quite neat. So if I say in here south and then names, and if I run this test, check this out, you can see the output in here. So it's the same as the one we had above. So this is how you use flat map. If you have any questions, please do let me know. Otherwise, catch me on the next one. You saw how to use flat map with lists right here, and you saw that we had a list of strings, and then in here, when we use the flat map, we basically say flat map and then list dot and then stream. Now what this is right here, so I want to make sure that you fully understand this because it's not quite clear from the previous video. So here you are saying list.stream, and basically have a look what it says. It returns a sequential stream with this collection and its source, right? So all it does, it pretty much just spreads out the lists, combining it into one single list. Now to give you yet another example with flat map, so in here, let me just have a new test. So test method, and then I'm going to say flat and then map with optionals. There we go. And inside here, let's have a list. So we're going to have list.of, and we're going to have two optionals. So optional dot and then of, and then here could be any string. So I'm going to say amigos and then comma, and then duplicate this, and then here I'm going to say code, right? So now have a look. We have a list of, so I'm going to say optionals. So we have a list of optionals. Now if you want to flat map the optionals, as we've done with lists, is as follows. So you say optionals dot and then stream dot and then flat map. Now this time you're not going to use list and then column and then stream. Instead you're going to say optional and then dot stream, because that's the data type that you are performing the flat map on. So hopefully this now makes sense. And then obviously I can say dot and then collect to a list and extract this to a variable. So here I'm going to say amigos and then code, and now you should see that. So let me actually name this as list basically. So now if I say south and then list, hopefully you should see that we have a list of strings and not optionals. So have a look. There we go. So ignore this one right here, is this one that we're looking at, right? So amigos and then code. So before it was a list of optionals, but now it's simply a list of strings. So basically the data type inside of those optionals. So hopefully this now makes fully sense. And if you have any questions on flat map, please do let me know. Otherwise, catch me on the next one. In this section, let's learn how to perform statistics like SQL with streams. So sometimes it's really good when you have a large data set and you kind of want to pull out statistics such as finding the count, min, max, average, so on and so forth. So in here, open up the statistics with streams class, and there is this test called count. And in here we have the list of cars. So what we want to do is, let's just see the JSON object, open up resources and then cars and have a look. So we have in here, we have a bunch of cars, but basically let's count all the Ford. So the make, where the make is Ford right here. So to do so, let's open up the class once more. Let me collapse this. And the way we're going to do it is by saying cars dot and then stream. Now we want to filter. So you've learned about filter. So this will take the car, and I want to say car dot get and then make dot ignoring. So ignoring, so equals ignoring case, and I want to say Ford. Then what I want to do is say dot and then count. And you can see that this gives me a long. So here, let me just extract this to a variable, count, and now I can say south and then count. So you can see how powerful is this. So instead of you having the count and then loop through one by one, so here you would basically do something like this. You'd say int count equals to 0, and then for, or mock data dot get cars dot for each, and then for each car you could do that, and then you'd say if car dot get and then make dot equals or ignore equals, and then inside you would say count plus plus, right? You've done this a bunch of times, right? But instead, have a look how clean this is. So we filter where the make is Ford, and then we count in here, right? So this is quite cool. So let me just delete this because this is imperative and we're not learning imperative programming in this course, and instead we are learning about declarative approach. So here, if I run, let's see how many Fords that we have. There we go, 104 Fords, right? So out of 1000. So this is quite cool. So obviously here you can then obviously have, for example, filter, and then you could say something else. So car get and then the year. And if I go back to cars, so let's just say anything greater than 2010. So dot and then get year dot and then int value in here greater than 2010, and I can actually do this, so I can remove the unboxing, and there we go. So now hopefully we'll have less cars, and before it was 104 and now we only have 10 cars. So you can see that this is quite cool. So this is how to perform counting with Java streams. Still within statistics with streams, let's find how to use the min method without using a comparator. So before, you've seen that we used a comparator. So what we want to do is let's basically find out the cheapest car in our list. So here, let's say cars dot stream dot, and then here I'm going to say map to a double. I'm going to get the price, and inside, so in here I'm going to say dot and then min. So if I extract this to a variable, I just want to see that this returns an optional double, but what I want to do is, so here I can say dot, and I have a couple of options there, so I can say or else, right? Because maybe there isn't a minimum car or the list is actually empty, right? So here I'm going to say 0 and extract this to a variable, and in here I'm going to say min. So now if I say south and then min, you can see that this is like saying select the minimum car, like in SQL, and the minimum car price is 5,000 in here. Now if we want to find out the most expensive car, let's just take all of this, and then inside of max I'm going to paste that in, and here let me just delete this because it's a duplicate, and instead of min I'm going to say max, and nothing changes. So this will be max as well, and there we go. So if I run this, there we go, have a look, the most expensive car is almost 100,000. Next, what I want you to do is to find out the average car price. All right, so to find out the average is kind of the same thing as before. So let me just delete that and then paste what I had before, which was I think from min. And in here, instead of min, we change this to average, just like that. And I've messed up in here, so it should be just like that. So the only thing that changes really is this part right here, and you can see it's almost the exact same thing. If you want to find out the sum for all the cars in here, what you do is, so again, let me duplicate all of this. There we go. And instead of min in here, so instead of min, you say sum. And this does not have a double because it will either give you the sum, right? So if there isn't anything, that will be 0. And this should be sum, just like that. And you can see why that we can invoke sum, and that's because we are mapping to a double. So if I was just to say map in here, have a look. So I cannot invoke sum, right? So I actually need to map to a double in order to be able to invoke sum. So if I revert that, and let me just run the average. So I just want you to see how much is this. There we go. So 52. I think we've done this before in one of the exercises. So 52,000, that's the average car price. And if you want to find out the sum for all the car prices, it's a very big number, right? So here, what we can do is say big decimal dot value of, and then sum. So if I run this again, you should see that now we have the number formatted correctly for us to read. This is all for this video. If you have any questions, please do let me know. Otherwise, let's move on. So in here, you've learned how to count. You've learned how to find the minimum, the max, the average, the sum. Now, there is another way that you can grab all of that information in one single go. And that is using the summary statistics. Now, just to be clear, this is a little bit more expensive, but it gives you all the data in one go. So sometimes you might want to have the information in one go, then use the summary statistics. And it goes as follows. So here, just say cars dot and then stream, and then say dot, let's map to a double right here. And depending on your data type, you can map. So here, remember, so map to int, to long, to double, and you've got also flat maps, so on and so forth. But here I want to map to double. There we go. And what I want to map is the price. And let me put this on a new line. And what I'm going to do is dot and then say summary and then statistics. And that gives you back a double summary statistics because of the data type. So now I can extract this to a variable. So I'm going to call it as statistics. And now I can just say south and then statistics and then dot and then have a look. We have get max, average, sum, count, min, so on and so forth. So let's just get all of those. So let's just start with count. And we also, and then we also want, so let me just duplicate a couple of times. So we have the count. Let's get the min. Let's also get the max, just like that. We also needed the average. And finally, I think we have sum as well. There we go. And let me see whether I forgot anything else. So dot. And yeah, it looks like I got everything. So also you can see that it has accept, combine, so on and so forth. But this is more on the functional style. So if you've missed the functional programming course, go ahead and check it out. So here, now I can just run the test and we get the exact same information as before. Have a look, but all in one go. And you saw that here we can say big decimal dot value of, and then in that, run it again, and we should have a proper number this time. There we go. So this is pretty much it. Use this when you kind of need pretty much like all of them. If not, just use the appropriate method because it's much more efficient, as you don't have to perform extra work and then not use, for example, any of these methods that it has to give you back, right? So if you have any questions for this section, please do let me know. But you can see that you can actually perform queries like SQL with streams, which is really, really awesome. This is all for now. Catch me on the next one. If you know some SQL, then you'll be familiar with group by. So this statement groups rows that have the same values into summary rows, like find the number of customers in each country. So in here, it says that it kind of works well with aggregate functions, count, max, mean, sum, and you've seen that we've learned this, and also average. We've learned this with Java streams. Now let me teach you about the group by or grouping by. So in here in this website, which you can find a link under the description of this video, if I scroll down, they have a demo database and they have some examples where we can try. So here, if I click on try for yourself, so this kind of opens up a new tab, and I'm going to say run SQL. And if I scroll down, this gives me that 3 people are from Argentina, 2 for Austria, 2 from Belgium, 9 from Brazil, so on and so forth. Well, we can actually do the exact same thing with Java streams. So in here, let me open up IntelliJ and open the grouping data.class in here. And let's fill in this very first method in here, or test. So simple grouping. So let's say that we want to group all the cars by make. We want to know the list of cars by make and grouping it at the same time. So the way we do it is, let's say mock data dot get cars, and let's stream. And what we're going to do is we're going to say dot collect, and you've seen collectors to list to set, but what I want is collect, and then inside I'm going to say collectors dot, and then have a look. We have a bunch of these collectors that we can use, but the one I'm interested is this one here. So grouping by. So this one right here takes a couple of things. So it takes the classifier or the classifier plus the downstream, so on and so forth. So what I want is the first one, and here I want to group by the car and then make. So make, just like this. So this now gives me a map of list of cars. So here, let me just say map, and let's loop through this. So to loop through this, let's say map dot, and then for each, this takes a by consumer, so S and then cars. Now S is the actual, so is the actual make. So here I'm going to say make, and then plus, and then S, which is the actual make, because we are grouping by the make, and then the, so, and then here we get back a list of cars. So these are the cars. So now here we can say cars dot for each, and then system dot out column print line. And also let me just say at the very bottom, so south, and then just a couple lines just like this, so you can see the output properly. Now let's run this and see the results. So let me run the test, run, and check this out. So have a look, make Lexus. So these are all the Lexus, have a look, including their models. So we have a couple of Lexus, we have Subaru. I haven't seen this brand for a long time, but you can see how he actually grouped the results for me. Make Chevrolet, and all the Chevrolets. If I keep on scrolling, oh, there's a bunch of them. So we have Citroen, only one, Fillmore, just 2 cars. I think this is Aston Martin, 2 cars, Chrysler. There's a couple of Chryslers, Infiniti. I've never heard about this one, but you can see how it's like doing SQL, right? So we actually group the data by, so in here, by the make. Obviously you can do other stuff, and in here we're just streaming and then collecting and grouping. But if you want to filter, map, so on and so forth, you can do all of that good stuff. So still within grouping data class, in here let's learn how to pretty much just perform the grouping and counting. So in here we do have this list of names. So let's say that we want to find out the number of occurrences for each name in this list. So John is in this list twice, Mariam once, Alex 3 times, Muhammad sallallahu alaihi wasallam 2 times, and then we have Vincent, which is once in here. So the way we do it is as follows. So here again, anytime that you work with streams, you know that you need to say .stream, and inside what I'm going to do is immediately collect. So I'm not going to have any other intermediate operators. So collect, and then let's say collectors dot, and then grouping by, and this time we're going to pass the classifier and then the downstream. So here if I press Control space, so you can see that this is a function, so s and then the object. So I'm going to say s and then return s, and the downstream here will be collectors dot and then counting. So there you go, and let me extract this to a variable. So this will be let me just say map in here for a second. So names and then .stream collectors grouping by s, and then this, you'll see what this is in a second, but then here we're actually counting each of the occurrences. So let me just say south and then map, because I want you to see the output. So let me just right click, run the test, and check this out. So this is a map of each of these strings right here, and it's telling me the number of occurrences. So have a look. Alex 3 times, Vincent 1, Mariam 1, so on and so forth. So this is kind of cool. Now this right here, we can actually simplify this, right? So this is the identity. So this is the identity, and the identity is each of these elements. So here I can say function and then dot identity. So now I need to indent this, and there we go. So this looks much neater. And if I run this once more, there we go. You can see that we have a map and it's the exact same output. So obviously you can do other things with this map, but I'm just showing you how to basically group and at the same time count the number of occurrences for each element. So there you have it. So you can see that streams and grouping by, it's really powerful, and you can do a bunch of things depending on your use case. But if you have any questions or anything that you'd like to learn how to do, please do let me know. Otherwise, let's move on. All right, so let's learn how to sort data using streams, and you'll see the power of it. So the same with SQL, sometimes you want to order by the ID, you want to order by the name, so on and so forth. You can also do the exact same thing with streams. So in here, open up the class sorting, and I have this very first test, sorting stream of elements. And what we're going to do is, let's say that for this list, we want to sort by the first name, right? So we want to get everyone by the first name. So here, if I say people dot, and then as always stream, and then here, let's say dot, and then map. So let's map the first name for everyone. So here, get first name, and say dot, and then sort. And to be more specific, sorted in here. Now let's collect this back to a list. So collect back to a list, and let's extract this to a variable. And here I'm going to say sorted. There we go. So now if I say south, or let's just loop through this. So sorted dot for each, and then system dot, and then out colon, and then print line. So if I run this, have a look. There we go. So you can see that, have a look. All the names are now sorted. So A, and then it will go all the way to B, and then C, D, so on and so forth, all the way to Z. Have a look. So this is how you use streams to sort your collections. So if you want to have the reverse sorting, you can just basically, let's just take all of this, and then here, let me just paste this test. So it's the reverse. And in here, what you do is inside of this sorted, you can say comparator dot, and then have a look at the methods that we have in here. So you can see that we also have reverse order in here. So here, let's just add reverse order. Now, if I run this, this should give me now all the names starting from Z and then all the way down to A. Have a look. So this is quite cool. Now, one thing with sorting in here, so here you see that we actually passed no arguments in here, and then here we pass a comparator, right? So if you're not too familiar with comparators in Java, and basically what a comparator is a functional interface which is used for comparing objects. So here, if I extract this to a variable, have a look. So this is the comparator. And the reason why I'm saying this is a functional interface is because this comparator takes a string and then it performs the reverse order in it. So if I press command and then just put my mouse in here, have a look. This is an interface. So the comparator interface, and then we can use generic. So in our case, we want to take a string. But if you are working with integers, you can say int, so on and so forth. So I usually like to extract these two variables so you see exactly what is happening. But most often you'll have it inlined like so. This is all for now. Catch me on the next one.